Alright, so today we'll be talking about properties of parallelograms. These are special types of quadrilaterals that have opposite sides that are parallel. Okay? Alright, and basically we'll be talking about what a parallelogram is and what it means. Okay, so now we have already talked about parallelogram, and it's a special type of... We're going to go into the properties of parallelograms. Opposite sides are just obviously opposite sides. One over here on the bottom, one at the top, one on the left, one on the right. Those are opposite sides. Opposite angles, lower left, upper left, lower right. So those are the definitions we need to know. Now, consecutive angles would be ones that are next to each other. You could also call them adjacent. Okay, and they have some special properties, especially when we're dealing with parallelograms. Alright, but first off, the most important thing is opposite sides are parallel. Okay, also opposite sides are congruent. So these bad boys are congruent, and these bad boys are congruent. So those are some nice properties to know about parallelograms. Now, there are some theorems in your book that say if all the sides are parallel, then if opposite sides are parallel, then you have a parallelogram that has opposite sides that are also congruent, and you could say vice versa. If you know opposite sides are congruent, then you're dealing with a parallelogram, so the converse works here as well. Okay. Another thing too is that the opposite angles are going to be the same, so that's going to be equal to that, and this is going to be equal to this one. Okay, so that's another nice little property. Also, these angles add up to 180 degrees. They are supplementary. Okay, so that's pretty nice. But not only just those two, but the ones on top as well. So consecutive angles are supplementary. So that's a nice little property to have. Okay, now another thing that also happens too, and let's use purple, okay, is the diagonals of parallelograms. Some really cool stuff to work with here. Now the diagonals will bisect each other in a parallelogram. Okay, and since I'm running out of hash marks, I'll use a V to represent 4. Alright, but they will bisect each other, so that's a nice little property of parallelograms that you can use. Now, can you have a whole bunch of stuff that just works that way across? Yes, you can. Parallelograms also explain some nice little properties too, especially this one, the 3 parallel lines rule. Okay, so if we have 3 parallel lines with 2 transversals, okay, if I know that these 2 are congruent, then I also know that these 2 are congruent as well. So that's a nice little property. And I also know that if this angle is congruent to this angle, then this angle is also congruent to this angle. So that's some nice little things that just work with it. Okay. Alright, so that's some really great, amazing stuff that you can work with properties of parallelograms. Do you need to know the actual definitions? Yes. But you can always use definition of a parallelogram to explain a lot of these properties that I just showed you. Okay, but please understand that when you're working with this stuff, you do need to take your time and work with it. And I almost forgot the most famous one of all. Now, if you're... Obviously, you need like opposite sides to be parallel and stuff. But here's an interesting property. What if you just know one pair of sides is parallel, of opposite sides, but also congruent? Then that means that we are dealing with a parallelogram. Okay, so this is a cool little property that you can take the shape with just these 2 pieces of information and actually make it a parallelogram from there. So please take your time, work with this carefully. Remember, set up your algebra equations based upon these logic constraints that we have. Okay? Alright, that's it for properties of parallelograms. We'll talk about more specific ones next time.